Okay, so we know that molecular formula gives us the actual ratio of the atoms present in a compound, and this chart here will give us the distinction between what empirical formula is compared with molecular formula. So in this particular lesson, we're gonna know how to solve for the molecular formula, knowing that the subscripts of the molecular formula came from the subscripts of empirical formula being multiplied to a certain number, to a certain multiplier. So now we're going to discuss how to be able to get that multiplier so that from the empirical formula we will be able to get the molecular formula. So let's go over this problem right here, the first problem for this lesson. So let's read the problem all together. A compound has the empirical formula CHO. So CHO are all capital letters. That means it is composed of carbon, hydrogen, and oxygen, all of which don't have a subscript. So that means they're understood to have one each. Okay? Next sentence. If the molecular mass of the compound is 116.08 grams per mole, what is its molecular formula? So we're going to get the molecular formula from the given empirical formula. To organize the entire step, we're going to use this chart to make sure that we don't miss a single step. So we're going to utilize this chart. So let's begin. The first entry to the chart is the empirical formula. The empirical formula is actually taken from the given in this case. So it's taken in the given because it's mentioned here. Empirical formula of CHO. So whatever is the empirical formula put in there, that will be written under the column of empirical formula. And once we are done getting the empirical formula from the problem, we are now ready to get the empirical mass. So empirical mass, how do we do the empirical mass? This is the same way we did the molar mass calculation. So list our elements first from the empirical formula. We have C, then we have H, and then O. We separate them, and then we put the quantity. The quantity will be the subscript, and because we don't have any subscript, so each one of them has one of each kind. Okay? So we have one C, one H, and one O. And then after that, the same way with molar mass, we're going to multiply this with the values found on the periodic table of elements. So C on the periodic table is 12.01. So you write that down, 12.01. Hydrogen on the periodic table is 1.01. And oxygen is 16. And now we don't really need a calculator for this because it's just times 1 all throughout. So we will rewrite those masses here, all times 1, so we will get the same values. After which, we know that after multiplying, we're going to add all of them. So we're going to add that in our calculator this time. So we have 12.01 plus 1.01 plus 16. Then we get 29.02 grams per mole. And that is our answer for the empirical mass. We're going to need this mass to calculate for the ratio. The ratio here has a formula that is placed in your chart, in your table. And make sure that if you're taking notes of this, you have to write that down. So what is the formula for that ratio? It says molecular mass found in the given divided by empirical mass. So let's look at the molecular mass. It says it's found in the given. So let's look for that in the problem. So here it is. Molecular mass is 116.08. So all we need to do is put that here. 116.08 grams per mole. Make sure that you copy properly so that you don't get the incorrect value later on. And it says divide, so we put the divide line there, divided by empirical mass, which was the mass that we solved a while ago, which is 29.02 grams per mole. And obviously here, both are grams per mole, so we cancel out the units. Okay? Then we put the equal sign. Once we've canceled the units and we got all the values, we are now ready to divide them in the calculator. So we have 116.08 divided by 29.02 equals, so we see it's a whole number, 4. So you're going to write that whole number here, which is 4. 4 being the ratio after dividing the molecular mass by empirical mass. Now, your question might be, will we able to get always a whole number, Miss Narca? Not necessarily, but sometimes you might get a 0.999. A 0.999, the same with empirical formula, we can make it a whole number closest to it. Another possibility is you might get something like a 0.0. So for example, you may get a 4.01. A 0.01, anything that's 0.0 something, you can drop it off and treat it like a whole number. So a 0.99 and a 0.0 something can be treated like a whole number like this. Now, in what case will it not be a whole number? The cases will be the same with empirical formula. You might get a 0.5 or a 0.3, which is in this case we don't have that yet. So if ever you don't get a whole number because you get a 0.5 or a 0.3, then you should be able to do the next column, which is multiply till whole. Okay? But in this case, because we get a whole number, so for this type of problem, we will skip this. We will skip it because it is already a whole number. And because we are skipping this, so we will be using the 4 already as our multiplier. So what does that mean? How will that look like as a multiplier? So your CHO empirical formula, we are going to multiply all its subscript by 4. So that 4 here will be distributed to every element inside your empirical formula. And this is so easy to multiply because our empirical formula are just all 1. So 1 times 4, everything will be a 4 here. So we will now get an answer of C4H4O4. And that gives us the real actual ratio of carbon, hydrogen, and oxygen. And we can rewrite this answer in here for our final molecular formula answer. So C4H4O4. And that is our final molecular formula for this particular problem. Now, before we forget, again, when will we not skip this? What are the possible answers that we don't skip this particular column? So let me just put some little reminders here for you, okay? When will you not skip? So the reminders for this part. You won't skip when you get a 0.5 or a 0.3. So anything that has 0.5 or 0.3. If ever you have got you get a 0.5, you have to multiply it by 2 to make it a whole number. And if you get a 0.3, you need to multiply it by 3 to make it close to a whole number, which is a 0.9, which you can round up to its whole number already. So these are the only 2 possibilities under this multiply till whole that you can get when you get the ratio here. So any of these 2 possibilities. If you don't get these 2 possibilities, that means you get a whole number or very close to a whole number. And this is the entire process of getting the molecular formula of the compound.